Welcome to my session. So in this session, we're going to explore how to use DSPy and MLflow to build GenAI applications or agents in a fun way. And today's agenda, we'll talk about, we'll do a full introduction to DSPy, then do a brief introduction to MLflow, only covers the part we need to use in DSPy development. Then after slides, we'll see a few code demos so that make more sense. Cool. I always start with this question, what is DSPy? So DSPy is a GenAI authoring framework that simplifies the development of GenAI applications. I mean, this simple sentence doesn't make any sense to me, to be honest, because the bar for building a GenAI framework is super low comparing to building like a PyTorch or TensorFlow. So we have so many options over there in the market. So are we just reinventing the wheels? The answer is no, but let's explore together why it's no in this session. Let's talk about the problem we're facing when we started to build DSPy. Since the success of ChatGPT in 2022, we are seeing the rise of compound AI system. Compound AI system is like a system has multiple modules, and each module could do LLM calls or run custom functions, and combining all them together makes you a very powerful system that can do RAG, knowledge-based QA, or generate code of high quality. But we are all facing a problem called prompt engineering. We do prompt engineering because we know that with better prompts, we get a higher quality response from the LLM. But the problem is prompt engineering is very messy because we do changing the prompts based on what we think could make a better prompts, but LLM may not think in that way. What that means? That means we may end up with 50 to 100 very long prompts stored somewhere, and it's hard to trace back which is good one, which is a bad one. Making that even worse, if you change your LLM behind the scene, you start over. So all that you did was nothing. And we have another problem coming from the frameworks. I've been hearing people saying frameworks are powerful and powerful troublemakers. Because it's with the frameworks, instead of focusing more on writing my custom logic, I'm more focused on learning the frameworks, which is nonsense. All the purpose for having a framework is easy to use, save my time so that I can focus on my business. And what that means is to migrate to some framework, it's a lot of time. If I want to get to another framework to migrate off the current code, it's a lot of time again. That is what DSPy is trying to solve. So let's answer the question, what is DSPy again? So DSPy is a lightweight, flexible framework which is easy to migrate into and easy to migrate off. We simplify the interaction with the language model by transforming the prompt engineering into something like calling a function with well-established inputs, outputs format. And DSPy provides you automatic program optimization. We do prompt optimization, and we can also fine-tune the LLM weights behind the scene through something called DSPy Optimizer. And DSPy is ready for production. We have streaming, async, high concurrency cache out of the box so that you can focus more on building a custom logic. This may not make sense to people right now, and after talk, I hope that makes more sense. Okay, let's dive into how to use DSPy. So we start from DSPy programming, which means how to build a GenAI application with DSPy. So DSPy programming is based on the signature and the module system. Signature is DSPy.signature, module is DSPy.module. Let's take a look at them one by one. So signature defines the inputs and outputs format of your LLM interaction. What that means? In normal context, when you query the LLM, it's string in and string out. But in the context of DSPy, it's more like you are calling a well-established RESTful API, but you define the input and output at the client side rather than the server side. This is through the DSPy.signature. Let's take a look at an example. So this is some signature I built for myself to learn Japanese. I want the input to be a simple English text. I want output to be Japanese text, and some other grammar information here. So this one is called translation, subclassing from DSPy.signature, and there are 5 important parts in the signature. The red box, the docstring part, it's like a high-level description of what we want to get from the LLM interaction. And the orange box is a field name, like it could be like input field or output field. Input field is how you set the value when you call the LM. Say like I give that an English text. And the output field name is how you read the response from the LM. Like if I get response from LM, then I can do response.Japanese text. That gives you the text without needing you to parse anything. The purple box is like some additional information to the fields. Sometimes the field is not self-explainable. And the green part is a type hint, so that like the output is already in the type I want that to be. No parsing is required. So signature, we have the static information, which is not enough, because we need to call the LM to use the signature. This is through the DSPy module. DSPy module is the core unit of a DSPy program. And we write all the logic inside DSPy module. The simplest module, but also the most important, is DSPy.predict. It is bundled with a signature and simply calls the LM with a signature. No other logic there. Modules are configurable, it has future examples, and you can specify the LM to call that, has some other fields. And I'll say that one important thing about module is super flexible. We don't restrict you something like you can do or cannot do with the modules. You can simply subclass from DSPy module, write your own program, like a custom module, and override the forward method to put anything there. This is pretty wild. You can do anything in the forward method. You can, of course, call DSPy modules, but you can also call like LangChain modules, Agno agents, or like LangChain to MCP tool. If you want to train a model, you can also do that in the forward. So this is why we say like DSPy is easy to migrate to, because you just put your code into the forward function. You don't need to change anything. If you want to use DSPy module, you can change part of your code to use DSPy module. And one day, if you hate DSPy, I hope not, but you want to migrate off, just take the forward method out. This gives you the code you want. Let's put them together to form an end-to-end workflow. So like the first step we need to do is pick a LM behind the scene. Then let's say we build a sentiment analysis app, like so we define a signature, take in text, outputs a sentiment. We feed the signature into DSPy.predict, which just to do LM calls. Then call the predict with the input field. You see, like we do text equals to something, then read the response with the sentiment output field. That's all you need with the end-to-end workflow. And we're missing one thing, what is actually, we only have one slide for this, but this is actually the most important slide in DSPy. I call it DSPy magic. This is called DSPy optimizer. So like what that does is after you build your program, you spin up a DSPy optimizer and prepare a data set. Data set could be as few as like 20 data records, and also give us a evaluation metric. The purpose is that we need to understand what is a good program and what is not a good program. With those two, we can start to search for a better prompts or even twin our weights behind the scene. So like to use the optimizer, you just like send the like training data set and the evaluation metric to the optimizer and call the compile method to kick off the training process. And then the return the program will be of the same structure as before, but I have prompt being a better one. So the one thing I want to call out here is I've been seeing a pattern. People like, the first reaction hearing this, if okay, this is good, this is cool. But like come to real production, they're still sticking with like doing custom prompt engineering, because if they don't want to spin up like a data set, this is like overhead, and then they don't do DSPy optimizer. But the problem is, if you do serious productization, you want that to evolve along with the time. You want to keep understanding the new data and to do manual every time. To keep that manual every time is really time-consuming and unreliable. But DSPy optimizer is built by our research team with lots of experiments. This is trustworthy. And that can also help you build a high-quality future example, not just like vibe coding or something, twin the prompts. So this is really good. Give that a try. That is everything about DSPy. Now let's talk about like MLflow. This will be very short. So what is MLflow? MLflow is an open source MLOps and AIOps framework that can help you like build GenAI applications throughout the full life cycle. And both the server and the client of MLflow is fully open sourced. You can spin up your server. But if you don't want to do so, you can use the, like, I cannot see that, it's in the bottom. Databricks has some like free trial edition, and also we announced that today you can give that a try at signup.databricks.com. I'm not sure if that's all right, but yeah. Cool. And we have two things we want to bring into DSPy from MLflow. The first one is MLflow tracing. So what is tracing? Tracing basically means we record the inputs and outputs of the intermediate steps and captures a hierarchical call stack, which means which function calls which function. This is very important because like in DSPy, after you build a DSPy program, you only get the inputs and outputs. You don't know what's happening behind the scene. Like if one LM call fails for some reason, it's hard to tell why that's failed. But with a trace, it's easy to see what happens behind the scene. To turn that on, it's just one line. It's MLflow.dspy.autolog. And this is what a trace looks like. We trace 4 things inside DSPy. We trace every module call, no matter if that's a top level or like child module call. We also trace adapter. We didn't mention adapter, but like, it's very simple. So like in DSPy, we call the DSPy program with structured inputs, but there has to be one place we transform the structured inputs into a prompt. This is through adapter. And the adapter also parse the LM response into a structured output, even if the model doesn't support native structured output. And the LM call is traced, of course, and tools are also traced. Tool is important for building the GenAI agents. So every tool call is being traced. We'll see that in a demo. Cool. And this is just a demo on how to inspect the actual prompt to send to the LM through MLflow tracing. And yeah, like this is something we just built. Is a DSPy optimizer is also being tracked by and traced by MLflow. So like many people, like if you ever used the DSPy before, DSPy optimizer looks like a black box. But like with the MLflow tracing, you can understand what's happening behind the scene. You can see how we evolve along with the time. We log every candidate program. We're trying to evaluate, so you can see the metrics evolving along with the time. And this is another size optimization. And the last thing we want to bring from MLflow is the packaging and deployments. So like after you build your program, you want to serve that for productionization purpose. You just do MLflow.dspy.log model, put your model there, and give that input example. Then you just do a few clicks. Right now, just do a few clicks. Then the serving endpoint will be up on Databricks platform. It's very easy, even more like a no-brainer there. I'll show you in a demo as well. Cool. And if you know something called agent framework in Databricks, you can also deploy that to get a playground UI to play with the program. Cool, that's about the slides. Now let me show a demo. Cool, let's take a look at the demo. Yeah, so you first get to configure the LM behind the scene, and this is following the Light LM like format. So it's provider name followed by the model name. You can pick whatever is supported by Light LM. Then we turn on the MLflow autologging, which turns on the tracing for you through MLflow.dspy.autolog. And as we say, we just say we need let's take a look at a very basic workflow first. We build a signature, do sentiment analysis. We take a text and context as the inputs, and the sentiment, which is integer at the output, and some description, and we restrict the range between 0 to 10. And this is called pedantic constraints, which is fully supported by DSPy signature. And we just send that to a DSPy.predict, and call that, and we can see the MLflow tracing is up. So you can see what happens behind the scene. So like this is the adapter formats your prompt, and this is actual LM call you send to the LM. And to read the outputs, you can just like, 1 second. You can do a dot accessor or access it as a keyword. Cool. And we have seen with the MLflow tracing, you can see the prompt we sent to the LM can be found here. It's multi-turn message, very familiar to people. But if you don't want to spin up the tracing, you can do that by do DSPy inspect history to print out the LM interaction history. Here we go. And you can also easily try different built-in modules, like say we have chain of thought, which gives you reasoning besides the defined output. And you can also like see the tracing here, or inspect that by inspect history. This is just all basic workflow. The next thing I want to show here is building a custom module. And the demo here is like a name the celebrity game. If you're not familiar with that means, is we have two players. Player one thinks about a name, and player two keeps asking yes or no questions to get to the final name. Could be a generic question or direct guess. So as we said, we subclass from DSPy.module. We override the forward method to do that. This is actually a human in a loop. Sounds cool, right? But it's just like asking for a yes or no here. And we have two modules here. We have question generator. I want to show the signature here is we taking the passive question and answer, generate a new question, and indicating if that's a direct guess or generic question. So we just keep going, and this is a running history. I find a name, and then tell the LM if that's yes or no, until reaching the end. I mean, this one that got it. So like doing reflection. The demo is just for fun, but like the real thing I want to show people is it's very flexible to do anything with a custom module. You can just write Python function. So it's just all Python. You can write anything. You can call LangChain tool, MCP tool, query your database, anything here. No restriction. And yeah, we kind of off time, but I want to see. The next thing I want to show is more complex. I want to build an agent. So this agent is doing like an airline customer service. I want that to be able to book a flight for the user and being able to cancel the itinerary or modify the itinerary. So we first define a data model. This is like the database schema, if that's a real production. Then we create some dummy data so that we can actually call the agent. Then we define a tool. This is important. When you define a tool in DSPy, you want to give the doctrine to describe what that does. And also you have the type hints for its arguments so that the LM can help you decide the arguments. So after you have the tools, we define a signature, which is the input and output of the whole agent. Here we're just taking a user request, and we output a process result. And we bundle them together through something called DSPy.react, which just let the LM decide if that to call a tool or draw the decision. And we call that with something, my name is something, I book a flight from this to that. Then here is when MLflow tracing becomes really valuable. You see we have multi-turn calls, and every turn has a different tool calling decided by LM. Without MLflow, it's just a black box. With MLflow, you can see what we do behind the scene. The first one thinks we need to get the user information, so we pull the user information and send all this back to the LM. Next tool call will be fetch the flight information. So we just keep going, calling the tool until we are able to book the itinerary. Then we finish and tell the user this is the final output with a confirmation number or so. If something is going off, you can see the exception here. Like for this one, for this query, we don't have a flight from SFO to JFK on this day, so you will see an error here. It's very easy to debug to see what happens behind the scene. All right, and probably the last thing I want to show is to deploy that on Databricks. Just deploy the airline service agent. So just call the DSPy log model, and this is the log for that one. Then you open that, you will get this. Like this is your log model. You just click on the register model. That will be registered in Unity catalog. Then on the Unity catalog, click on serve this model. That brings you to the serving UI. You just give a name, configure something, new create. That's all you need to serve the model. Very simple, right? Like you don't need to know anything about packaging, Kubernetes, nothing is required. Just do a few clicks, you serve the model. And this is, so I deployed that before the talk, so this is what that looks like. So you can use it through at any place, use your own token, and you can use Python client or just use curl. Cool. And if people want to stay around for another minute, this is how we use the DSPy optimizer. So we define the evaluation matrix. This one is a little complex because this is math equivalence. Then you download data set. This one we have an existing data set, but in real production, you may need to find your own data set. But as I say, you don't need the big data, like a fine-tune something. You just need 20 or 30, which is totally enough. And we get the data set, and we can turn on the MLflow tracking with a few more flags in autolog function. And we can evaluate the baseline before optimization. We see a score of 72. Then all right, this is called. Then we spin up the optimizer. MLflow optimizer is one of our most popular one, which does the prompt optimization, doesn't tune anything. So like we call it evaluate, well, we use optimizer, use a compile call to get a better one. And we can evaluate it after optimization process. We still get to 81. This takes about like 7 minutes in total, I think. And you can get like free bump. So this is just showcase how to use that end to end. Cool. That's all of the demo. And because we don't have a lot of time, this is very quick. If you want to like learn more about DSPy and MLflow, I do have a course on deep learning AI published from last week. Search for DSPy space course and space deep learning.ai. And it's like it's a short course, it's one hour, and I have more details for all of this. And I do have a brain data session from 4 p.m. today. If you want to learn more, ask questions, you can find me there. And my colleague Omar, who is also the creator of DSPy, will give a talk from 5:20. You can find a location, I forgot the location, but like, it's about DSPy 3. We are releasing a beta today. And so it will be really quick. You don't want to miss that one. Cool, that's all about the talk. Thanks for coming.